Okay, so the first become the first term, the outer plus the inner become the middle term, and then the last multiplied right here become this last term. And you already kind of know that. We kind of did that for warm-up. I checked our work right back here. Let's see. Remember when I checked our work? So I did the first right here, became x squared. The last, look at these two multiplied, became the 16. And then the outer and the inner, that is these two plus these two, became the negative 8x. So that's just a little review from the warm-up. So with that knowledge, we're now going to factor I'm going to write ax squared plus bx plus c. Standard form of a trinomial. Put it in a cloud. So this is the standard form of a trinomial. Ax squared plus bx plus c. Ax squared plus bx plus c. All right. So if we want to factor ax squared plus bx plus c, what has to happen is this. It's going to end up becoming two binomials. All right. These two terms So the first two terms multiply to become your ax squared. Okay? So I'll put a question mark here and a question mark here. Those two terms have to multiply. The first terms become the ax squared. Those are your f. That's your f, huh? I'm going to color code here now. These two terms, the last ones, have to become your c if you multiply them. That's your lasts. The first become the first term, the last in green become the last term. And then watch this now. The outers plus the inners. Okay? The outers plus the inners all will be in red. The inners, I'll put plus I, becomes your bx, your middle term. The outers in red plus the inners in black become the bx. The first in blue become the ax. The last in green become the c. First, outside, inner, last. Let's try it now. So right here I'm trying to color code here. Okay, that was what I was trying to do if my coffee kicked in. The blues multiply to become the first, the ax squared. The greens multiply to become the c. And then the red and the black add up to be the bx. There's method to my madness here.
We have to multiply the inners and the outers before we can add them?
No, we're going to multiply them. Yeah, we multiply these. So I love that question. Diaz, you're awesome. So, yeah, these are being multiplied, and then
Added together.
these are being multiplied, and then we add them after. They become like terms, in other words.
Mm-hmm.
In other words, watch this. I'll show you what I mean right now. The first example. Example 1. Factor, here we go now. Put your seatbelt on. 2x squared plus 3x minus 9. So let's go straight to the binomials. I know it's going to be two binomials. What's the stuff that's going to multiply to become that trinomial? What's going to be two binomials? We got to figure out what binomials they are, though. So I know here and here. Watch this now. Let me make it. I'm going to use the same color coding as up here. So the blues. So I know the blues are going to be the 2x. Let's see here. The blues here are going to become 2x squared. We just got to figure out some factors of 2x squared. I know the greens, watch this now, whatever goes here and here are going to become the negative 9. And then watch this now. The outsides multiplied plus the insides multiplied, I'm going to put a big plus there, is going to become the 3x. I'll put O plus I. Outsides and insides become the 3x. So we have to tinker with numbers, in other words. It's kind of like a combination code. We're going to figure out what, it's like a number puzzle in one sense. All right, let's start off with the first term. That's kind of easy. 2x squared. The only possibility for 2 would be what? 2x and 1x. So I'll put an x here, and I'll put 2x here. How about that? There's no other possibility for 2x. That's pretty easy. Okay, check. We're done with that one. Now I need to figure out some numbers that multiply to become negative 9. Use green, stay consistent. So factors of 9, not just 9, negative 9 would be, let's say, 3 and positive 3, or 1 and negative 9, or negative 9 times 1, right? Those are different possibilities I can start using. Because I need to put two numbers in this slot to become negative 9. So let's try the first one. Negative 3 and 3. Look at that. Negative 3 over here, positive 3 over here. Now let's see if it works. I'm going to see if the outsides multiplied plus the insides. Look at that's the red and black. The outsides multiplied plus the insides multiplied become the positive 3x. Let's see if it works. If it doesn't work, we'll have to go back to the drawing board and try a different combination. I'll stop right here. Questions?
Yeah.
They can make some drinks here. All right. Outsides multiplied in red. X times 3 is 3x. Insides multiplied in black is negative 3 times 2x. What's negative 3 times 2x?
Negative 6x.
Beautiful. Thank you, Gomez. And now I'm going to add those puppies up. That's why I put the plus here. I'm going to add these two terms up here now and see if they become positive 3x.
Yeah.
Do they?
Yeah.
It's negative 3x, huh? I need a positive 3x, but this,
Right.
if I add these puppies up, I get a negative 3x.
Sorry.
So I gotta do a little adjusting, tweaking. Don't get excited because I say tweaking. Everyone, like it. Years ago when the speed was all in vogue, everyone would go, "Oh, they said tweaking." Anyway, sorry. So do a little adjustments. Any ideas?
Switch the negative and positive.
Right. Look at this. Very good, Gomez. I'll put the positive over here, and I'll put the negative over there. Let's see if that helps. I think that'll do the trick. I could be wrong, but here we go. Let me start with the first again. FOIL. First, x times 2x is 2x squared. That's done. Outsides plus insides. Here we go. Outsides is negative 3 times a 3x is going to be a negative 3x. Right? Negative 3 times x is negative 3x. 3x times 2x is positive 6x. I'll put that in black. 6x plus negative 3x. Nice. It is a 3x. And then the 3 times a negative 3 is a negative 9. We're rocking and rolling. We found our factors, ladies and gentlemen. I'll put it in lavender. I'm going to circle in lavender. Here's our factors. I think that's lavender, right?
Around there.
Pretty color. Done! That's the stuff we multiply to get to the original stuff. Let's try number 2. Any questions?
None.
Let's do this. Let's try 5n squared. So I'm just throwing a different variable instead of x. I get kind of bored with x sometimes. Plus 19n plus 12. Let's factor this puppy. All right. I already know it's going to be 2 binomials. That's going to be the stuff I multiply to get to that trinomial. So let me stay with my color coding. First become the 5n. The last in green become the 12. And then the outers plus the inners. I'll put the O plus I here. FOIL. The outers plus the inners become the positive 19. The blues become the 5. And the greens become the 12. Okay? Start with the first. Again, 5. That's a no-brainer. There's only one possibility, possible pair of factors is going to be 1 and 5, right? So I'm going to go 5x here.
5n.
5n, my bad. Good looking. Times a 1n. That's easy. Wow. Makes life easy when there's just only one pair of factors. Okay, we're good there. That's taking care of the 5n. 12 is going to give us some trouble because 12 has a lot of factors, a lot of combinations for 12. So let me write them over here. Some factors of 12 off to the side. 4 and 3, negative 4 and negative 3, right? 6 and 2, negative 6 and 2, 12 and 1, negative 12 and negative 1. Boy, we got a lot of combinations here. This might make life hard because this is like process of elimination. That's what makes this sometimes a little time consuming, which is why on the assignment I only give you a little bit of problem, not giving you a bunch of them. It's just playing around with different combos. I'm gonna try the first combo. I see a bunch of positives, look at it. I see a bunch of positives everywhere here. So I'm gonna go with the positive combos, these. I'm not gonna worry about negatives right now. By the way, there should have been a negative 2, huh? Boom. Now, if I see a bunch of positives, don't worry about negatives then. That kind of eliminates that. Save some time. Let's try 4 and 3. I'll put a positive 4 here and a positive 3 here. And now let's see. So that takes care of our last. Look at 4 times 3 is 12. Now let's see if the outers and the inners make the 19. And we're in business. And just looking at it, I think they do. Very nice. 5n and 3 make 15n plus the insides is 4n. Nice. Rocking and rolling, 14N and 15N, if you add those puppies up, they make 19N. We found our factors, ladies and gents. Put in lavender again. This is the stuff I multiply to get to the original stuff. It's not that hard, not that big of a deal. All right. Got that one. Cool. This next one I want you to try on your own, please. Actually, you know what? Let's do one more. Factor. There we go. 3x to the third minus 8x squared plus 4x. Oops, 4x. All right, I used to be a pitcher growing up. I'll strike any one of you out on the field, and Rocha knows it.
No, you won't.
Anyway, I threw a curveball at you on this one. So,
You said that I can
no
hit
way,
it.
Boogie.
I
Doubted
can-
me already.
I can hit it, mister.
I can throw a pretty good, nasty breaking ball. But I kind of threw a breaking ball at you. What's a little bit, can anybody see what's different about this one than the previous?
Form.
Give it to me. What about it? Give me more. Go, miss.
So, I don't know what it's called, but I know we need to do it as one parenthesis.
Okay. What do you mean, do it as one parenthesis? Give me more. What are you talking about here? What's different about this one than the previous two?
It's raised to the third power.
Okay, I see a third power here instead of a six. In other words, it's cubic instead of quadratic. Remember, quadratic is second power. Also, so anybody observe something else? Rodriguez, Dominguez,
The
keep that on.
negative 8x is raised to the second power.
Okay, so the middle term is it's on steroids.
That's
The middle term was really just like before. Look at on the previous, it was just one variable. Now the variable is raised to the second power in the middle term. And the last term is also on steroids. It's got a variable where the previous two didn't have a variable, just a number. What we call a constant, just a number. So what we could do here is factor out the GCF. In other words, that factoring technique I taught you last week. Let's first take the GCF out. What's the GCF here? What's a factor that goes into every single term here? 1 always works. But if I factor out a 1, I'll just have the same expression. You're right. But something besides 1. They all share a factor here. I can take out. I can extract.
right?
This one doesn't have a 3. This one doesn't have a 3. X.
Oh.
Gracias. Look at. I'm gonna take an X out of every term. Watch this. Remember last week? We did this last week. Watch what happens now. 3x squared minus 8x plus a 4. That's the stuff I multiply to get to that stuff. So go write that down. So far, so good. Give me more. Quintana, what are we thinking?
The 8x squared. It's 8x squared.
Right. So so right now, all I've done is from here to here, I've just taken out the x. So this x and the trinomial are now the stuff I multiply to get to that original stuff. But now I'm looking at this trinomial here. I can keep factoring. I can make this into 2 binomials. This x will still be here. I'm bringing that down to our final factorization. But now I can start factoring this trinomial the way we have been. The x comes down. That's still part of the factorization. Remember, factors are just stuff you multiply to get to the other stuff. That's going to be in our final stuff we multiply to get to the original stuff. Now, let's go back to our first become the 3x squared. The last become the 4. And the outer plus the inner will become the negative 8x. So this is a little bit different. The curveball that I threw at you is just, hey, take out the, if you can take out a GCF, do it. We're able to take out an x. And that stays there. Just keep that to the side for now. Let's just focus now, we're just focusing on the trinomial now that resulted. All right, life is easy. 3x squared, that's a no-brainer. That's just going to be a 3x and an x. Actually, I should have put that in blue. Let me stay consistent with the color coding. So 3x, x. The last for 4, I can go 2 and 2 or 1 and 4. -1 and +4. Because look, we have a negative 8x, so we might have to mess around with some negative and positive shortly. But right now, I'm gonna stick with a 2 and a 2. How about that? But since I have a negative, I'm gonna throw a negative in there. Let me make it both negatives. -2 times -2 becomes +4. I see a negative 8x, so I know some negatives are gonna have to be sprinkled in this mix here. All right. Let's see the outers and the inners now become the negative 8x. Outers, 3x, -2 is going to be a negative 6x if my coffee's kicked in. -2 times x is a negative 2x if my coffee's kicked in. Wow, I got it on the first try. That's pretty cool. Check it out. Look at when I add. Rocha. -2x plus -6x. Nice. Look at that. Becomes a negative 8x. So look at our final factorization was all of this, including the x GCF we took out in the beginning. All that is the stuff I multiply to get to the original stuff. If you don't believe me, you can try it. You can multiply it all out later.
So that x just stays out there?
Right, because remember, factors means what's the stuff you multiply to get to the original stuff. If I multiplied this x, let me show you. You don't have to write this down, just watch me. So Diaz just asked a good question. What about that x? Well, that's part of the stuff you multiply to get to the original stuff. Remember, the original stuff is right here. This is the original stuff. I'm telling you that if you multiply all this stuff out right here, all of this, you're going to get to the original stuff. Let me prove it. Watch. You don't have to write this down, just watch Mungia prove it. X times 3x, x times -2, let's see. X times 3x is 3x squared. X times -2, -2x. Times x minus 2. Okay? Now, okay. Let's multiply now. First, outsides, insides, lefts. Okay. See what happens. 3x times x is a 3x squared. 3x squared times a -2 is a -6x. Actually, this is 6x to the third, my bad. Because look at x squared times x to the first is x to the third. 3x squared times a negative 2 is going to be a negative 6x squared. And then I got a negative 2 times an x is going to be a negative 2x squared. And then negative 2x times a negative 2 is going to be a positive 4x. It's starting to look like what we started off with. Right there. All I got to do is add those like terms in the middle there, right? This and this become negative 8x squared. Look at, there's a 4x over here. And I got the 3x to the third. So I multiplied it all out, and it became the original stuff. That's the original stuff we started off with, right there. That's why the x stays, because it's part of the stuff you multiply to get to the original stuff. All right, I just want you to try one on your own and go on to your assignment. It's a pretty basic day, so this is right now. That was example 3. So try example 4 on your own without a phone, because I know there's apps that actually do this for you. I'm aware of that, and on Friday's quiz, you're not going to be able to have a phone out. Just saying.
Wait, there's an app that gets you.
Oh yeah, there's all kinds of apps.
Damn, mister, you should let me know before.
I know how. My bad. Next time I'll let you know the cheat.
Make sure to post that little attachment, okay?
Got you. Here we go. Let's try this one. Factor, just show me when you're done. Just bring it to me in the back. Just one on your own. Factor, 3x squared minus 2x minus 5. Try that one for me.